Good morning. I'm Sangeeta talking about the directional derivative. Today I like to explain the definition of the directional derivative, the geometrical interpretation of this directional derivative, and some problems related to this directional derivative. What is the meaning of the directional derivative? We have in the last section, we know from the last session what is the meaning, definition and geometrical interpretation of the derivative. How it changes from this directional derivative. What is the difference between the directional derivative and the derivative? Derivative means a function f of xy is differentiable, and using chain rule, f is a function of x and y are functions of t, then df by dt is defined as dou f by dou x into dx by dt plus dou f by dou y into dy by dt. Next, I am going to define this directional derivative. Actually, this tells you how a multivariable function changes as you move along some vector in its input space. Suppose that is, we need a point and a vector in the xy plane. What is a change in the surface corresponding to at the point AB and corresponding to the vector u? That is, we are going to explain. Suppose this is a xy plane and we have to take a point AB and we need a unit vector u. Actually, the derivative is defined as definition is the derivative is defined as derivative of EF, derivative of EF at the point P naught, x naught, y naught in the direction of unit vector u equal to u1i plus u2j is a number. This is defined as df by ds in the direction of u at the point P naught is defined as limit s tending to 0 f of x naught plus su1 y naught plus su2 minus f of x naught y naught divided by s, provided the limit exists. Provided the limit exists. This is the directional derivative in a plane at the point P naught in the direction of u, and this is defined as du f. I know that you couldn't understand anything about this, so I'm going to explain the geometrical meaning. What is the meaning of this directional derivative? Suppose this is our xyz plane and this is any surface, this is some paraboloid. Okay, here I have to take a vector u at this point. This is a point AB. Correspondingly, suppose this is a image of this point f of AB. Corresponding to this vector u in the direction of u, I have to take a plane in this direction. I have to take a plane in this direction. Okay, this plane will cut the surface at some points. Suppose this is that point. This is the curve of intersection. This is a curve of intersection between this plane and the surface. Suppose this is a point AB. This is a point AB image. Okay. Next, to take the slope of the tangent at this point. This is defined as directional derivative. This is a geometrical interpretation. What was that? First, this is our surface. I need a point AB and a unit vector U. Next, I have taken a plane in the direction of U. Okay, this plane will cut the surface at some points. These some points will be a curve. Suppose this is that curve. This is the image of this point AB. At this point, draw a slope of the tangent line, and this is we are going to define as directional derivative. And the definition of actually the theoretical definition we have defined. This is the theoretical definition. Okay, I'm going to redefine this definition. We know that this df by ds at the point P naught in the direction of U is equal to dou f by dou x at the point P naught into dx by ds plus dou f by dou y at the point P naught into dy by ds. This is equal to dou f by dou x at the point P naught into u1 plus dou f by dou y at the point P naught into u2. This is equal to dou f by dou x at the point P naught into y plus dou f by dou y into at the point P naught into j dot u1i plus u2j. Okay, this is a definition. What was this definition? What was del f? This is the gradient vector. This is the gradient vector of f of xy at the point P naught, x naught, y naught. And this del f is defined as dou f by dou x into y plus dou f by dou y into j. If the function is f of xy z, then this will have one more term we have to add plus dou f by dou z into j. So I can redefine this definition of directional derivative as this is equal to del f at the point P naught dot u. This is a definition, or I can redefine this duf at the point P naught is equal to del f at the point P naught dot u. Okay, a direction is additionally we have added a direction in this derivative. That's the meaning. Corresponding to that direction, we are going to take the derivative. There is a difference between the derivative and the directional derivative. This is a definition. Okay, next I am going to explain one problem. Find the derivative. The question is find derivative of f of xy equal to x into e raised to y plus x into e raised to y plus cos xy at the point 2 0 in the direction of a equal to 3i minus 4j. So in the direction we need, in order to find out this duf at the point P naught, first we need u and P naught. Here P naught is equal to at the point 2 0, we know that. Okay, so u means we need a unit vector. Here the question they have given 3i minus 4j. This is not a unit vector. So I have to convert this as unit vector. This is equal to a divided by its modulus. This is a unit vector. So 3i minus 4j divided by square root of 3 square 9 plus 16, that's equal to 5. So 3 by 5 into I minus 4 by 5 into j is its unit vector. So in order to find this, we have duf at the point p naught is equal to del f at the point p naught dot u. So in order to find out this del f, first I have to find out this fx. Fx is equal to e raised to y plus y into sine minus y into sine xy, and the fy equal to x e raised to y minus x sine xy. So fx at the point 2, 0 is equal to 1, and fy at the point 2, 0 is equal to 2. So the gradient del f at the point 2, 0 is equal to I plus 2j. I plus 2j. Okay. So what is du f at the point 2, 0? This is equal to del f at the point 2, 0 dot u. This is equal to I plus 2j dot 3 by 5 I, what was that, minus 4 by 5 into j. This is our unit vector. This is equal to 3 by 5 minus 8 by 5, which is equal to minus 1. So this is considered as positive 1. So the directional derivative is equal to minus 1. Here the directional derivative is equal to minus 1. Okay, thank you. Next class we can discuss some more problems, and we can do the exercises also. Okay, thank you.